Clocks are everywhere. There are tiny clocks that people wear on their wrist, clocks represented by pixels in our pocket, clocks that wake us up. Almost every building has a clock. Heck, some buildings are massive clocks. They measure the thing that dictates our every move: time. But how come one of the most important objects in the world is so boring and overlooked? Today, I'm going to try to reinvent the clock. And maybe, just maybe, I'll create something that's more interesting than 3 hands and a circle.
So you're probably wondering, how are you going to make a clock that's different from every other clock? Good question. I want to take inspiration from the sun. Instead of clock hands that rotate from the center, I want to have 3 orbs of light that travel around this ring. Each orb will represent the second, minute, and hour. The first thing I did was start 3D modeling the clock design in Rhino, which is the 3D modeling software on my computer. This is a fairly complex design, so it's going to be essential that my model is dimensionally accurate. The design I came up with consists of the main chassis of the clock and 3 rings that rotate inside of it, which will have the little light orbs attached to them. After many hours of modeling and sourcing components online, it was finally time to get started fabricating. However, it would be nearly impossible to make this by hand at the accuracy required for all the parts to work together. So I decided to make a phone call to my friends over at Bamboo Labs, and they said they had just the tool for the job: the newly released Bamboo Labs H2S, which is their most advanced single nozzle printer to date. I'm a big fan of Bamboo Labs. Throughout college I've used many different 3D printers, and Bamboo Labs are far and away the easiest printing experience I've had, with the fastest printing speeds and also the best quality. One of the biggest hassles of 3D printing is drying and switching the filament. If you don't dry your filament, it can absorb humidity and affect the print quality. The H2S is compatible with the AMS2 Pro. AMS stands for Automated Material System, and it's basically this box that you can add up to 4 rolls of plastic filament. The AMS has a drying function that removes any humidity, and it's able to tell you how much filament is left. If you run out of filament, which I did many times during this build, it'll automatically refill with another spool and it resumes the print. And this saved me a lot of time, not having to go and manually refill it. So now I have a pretty solid 3D model that I think is gonna work, but there's no way of being 100% sure. And if there's one thing that I've learned about digital manufacturing, it's that you almost never get it right on the first try. There's always some dimension that needs to be tweaked for the final version, and so that's why I want to make a prototype. But if I made a prototype of the entire thing, that would be a lot of wasted filament. So instead of printing the entire clock, I'm going to think of it as a pie, and I'm only going to print 1 slice. And theoretically, that 1 part should be enough to tell if my moving parts are the correct dimensions. The most important thing is that these rings that the lights will attach to slide smoothly, and that all of the holes for the stepper motors and the electronics are the correct size. This project is hurting my brain. I exported a small piece of the clock and I imported it into Bamboo Labs software. I was able to send the print from my computer to the printer over my home Wi-Fi. A few hours later, I had my first prototype, which I was able to peel off the build plate. Okay, the print is done, so it's time to see if I modeled everything correctly, or if I need to completely remodel it. Okay, here's the base piece. Immediately, I'm thinking that this is too thick. I think it needs to be half of that dimension. Time to add the bearings. I added some bearings to this design, which will help keep each of the rings moving smoothly. Now for the moment of truth. That's nice. That slides pretty smoothly. Granted, there's only 1 bearing, and it would slide even smoother if I had all of the other ones. Now you're probably wondering, how are these rings going to move around? I'm going to use this timing belt in conjunction with a gear to make these rings rotate. And that's why I modeled this thinner section right here. The timing belt will get glued to the edge here. So that's pretty good. I would give it a solid 8 out of 10 for prototype accuracy. The main improvement that I need to make is thinning this out. This amount of material on the bottom is just unnecessary and it just thickens up the clock, which I don't want it to stick too far off of the wall. But before I can start printing the final version, there's a problem that I need to solve. This clock is 3 feet in diameter, which is quite large. And despite the H2S having a larger build capacity than most 3D printers, it's still not big enough to print it in one piece. So that brings me back to my pie analogy, because I need to split this clock into a bunch of different slices so that I can glue them all back together once they're printed. I've had Bambu's X1 Carbon for a few years now, which is their first flagship printer. For comparison, its build plate is 240 millimeters cubed, but the H2S is much bigger at 340 millimeters. I still won't be able to print the clock in one piece, but the larger build plate means that I have to split the print into less pieces than if I were to use a smaller printer. So all of the pieces are finally done printing. This is about 3 to 4 days worth of prints. And now it's time to glue them all together. I have a deep love for making things by hand, but my love for digital manufacturing has grown immensely because while the 3D printer is running, I'm able to spend more time refining the design and planning out the project more. I think every project you do can be split into conceptual work and handwork, and there are benefits to both. But if all of your time is consumed by fabricating parts by hand, that leaves you less energy for the thinking part of the project. Okay, this has been clamped up overnight. I put as many heavy objects on top as I could just to keep it flat. As I unclamped the two halves of the circle, some of the joints broke apart. Oh, okay. Damn. Well, this glue joint obviously didn't work. That's a shame. Okay. I hope this other one didn't mess up. I pretty quickly realized that I hadn't sanded the plastic enough, and there wasn't enough tooth for the glue to grab onto. I went back to the drawing board, this time making sure to scratch the pieces and using a combination of super glue and Gorilla Glue. I was able to get all the pieces glued together into a full circle. It was at this point I started to realize just how big I'd made this clock's diameter. Perhaps a little bit too big, but there's no going back from here. Now, it was on to printing the rings that would hold each orb of light. While building this clock, I got to thinking about time. I've never been good at being honest with myself about how long things are going to take me. I think it's a symptom of being an optimistic person. I'm always underestimating how long a task will take, and I think deep down, I know that I'm not being truthful to myself, but my eagerness in saying yes to opportunities always seems to prevail. So I just finished gluing up the second ring out of the 3 of them. This is the medium-sized ring. It's pretty warm out here and I'm sweating considerably. So I'm gonna take this inside so it doesn't warp with the heat. That's one thing you need to keep in mind when using PLA is that when it's exposed to heat, it has the ability to warp and bend in ways that you don't want it to. I think the first ring that I did is a little bit warped because I left it out in 100-degree weather, which was not so smart. I only have one more ring to glue up and then we can start assembling this clock and seeing how everything fits together. Being hopelessly optimistic has benefited me in many ways, but it's also hurt me. I've said yes to so many opportunities that pushed me to work harder, and in pushing myself, I've been able to get things done that I normally wouldn't have if I was actually being realistic with the time. The flip side of that is that it can be quite stressful and it can lead to burnout. It's time to see if this ring is actually going to fit into the main body of the clock. It's finally time. Oh yeah, that's pretty good. Except, I do think this is a bit warped, which is affecting how flat it's laying. But not to worry, it's not that bad. The one thing that I am missing in this equation are the bearings, and I think that would make it slide even smoother. Oh yeah, that's way smoother. That is considerably less friction. Those bearings are doing their job. Now the one thing I'm noticing is this ring is kind of catching a little bit. Some of these glue joints are a little bit uneven, but my thought is if I sand the edges and the faces of these joints, there's gonna be a lot less catching. Oh yeah, That's way better. So at this point I have the base of the clock all done and all of these rings assembled. Now you're probably wondering, how do I deliver power to each light orb if they're moving perpetually? The problem is I can't have any wires directly attached to the light because they would twist themselves infinitely and that just wouldn't work. So to solve this issue, I'm going to take inspiration from how electric trains work. I'm going to install 2 tracks of copper wire for each ring in the base. 1 track for positive and 1 track for negative. And on the ring, there's going to be 2 metal contacts that go directly to my LED. And the positive and negative contacts will ride along the copper tracks. I used thin CA glue and activator to adhere the copper track to the 3D printed clock base. I'd feed the wire into the groove incrementally, making sure to push it in well with a piece of scrap wood. This copper track idea felt like a complete gamble to me. In theory, as long as power was supplied to each wire and the metal contacts were always touching, it would work out. But I'd have to wait to test it out because I first had to figure out how to make each of the rings move. As I mentioned earlier, I'll be using a G2 rubber timing belt for the movement of the rings. This is the same type of belt that's used in 3D printers. I just had to figure out how to adhere the rubber belt to the inside of each ring. After testing multiple glues, I landed on rubber contact adhesive. I coated the belt with glue and the inside of the plastic ring as well. And once you touch the 2 surfaces together, it's an instant bond. With the timing belt sorted, I needed to address the metal contacts that would deliver power to each of the orbs. I hammered out some thick copper wire into flat contacts. After soldering a lead to each copper contact, I epoxied 2 of them into each ring. I needed a way to hold each ring down so that there was constant pressure on the electrical contacts. And my solution for this was printing some tiny clips on the H2S that hold the rings down. Now you've probably been wondering, how will I make the light orbs themselves? Each orb assembly consists of an aluminum heat sink to dissipate heat, with a 3-watt LED chip glued on with thermal adhesive. I went with the warmest color of LED I could find because I wanted these orbs to be reminiscent of the sun. My goal with this design was for the clock to feel almost planetary with the orbiting movement. After installing the orb assemblies onto each ring, I soldered in the power supply wires to each copper track. Now I figured to give myself a better chance of the rings making proper contact with the tracks, I would sand the surface of each positive and negative track. This entire project hinges upon these tracks delivering power to the LED. If we can't power the LED with these tracks, then this project is over. Because I can't think of any other way to get power to these LEDs without wires. Oh yeah. Okay, let's see if it actually works if I move. Oh, dude. Yes. Okay. Oh my god. What a relief. Oh yeah. Nice. Nice. This one works, okay. Heck yeah. That's a lot of weight off of my shoulders now. Now that I knew the lights and electrical tracks were working, I designed and printed some motor mounts on the H2S, which will snugly hold the stepper motors that'll power each ring. Hello, man. Sanding these little pieces. I made sure to thoroughly sand each surface, and this time I used some 5-minute epoxy. I wanted to make sure the bond between the mounts and the chassis were extra strong because I knew they'd experience some torque when moving the rings. I made a mistake while modeling the mounts, which resulted in part of the neighboring mount blocking the motor from sliding in. But after some quick modifications with the multi-tool, the motor fit in perfectly. So now I have these motor mounts
glued in place. And the way I designed it allows for a tiny bit of up and down movement so that I can really get the gear pressed tightly up against the belt.
This tiny tooth pulley is what came with the timing belts I bought, and they just slide onto the shaft of the stepper motors and tighten with a set screw. Now, with most of the body of the clock done, I needed to figure out a shade that'll diffuse the light orbs and fit perfectly within the 3-foot diameter of the base. I decided to put the Bamboo Labs H2S to the test by 3D printing a PLA mold that I can use to create the lampshade.
We cut the legs off of our pants, threw our shoes into the ocean, sit back and wait through the daylight, sit back and wait through the daylight, slip and slide on subway grades, these shoes are poor man's ice skate, fall through like change in the daylight, fall through like change in the daylight, I miss ya both lines of my road, some call it on my metro, maybe I'll paint them in my soul, maybe I'll paint them in daylight, like we could try to hang out this someday, I'll see without you.
I was pretty confident in my plan for molding this light shade, but I needed some advice before I risked destroying the mold that took me multiple days of printing.
Morley, what are your thoughts on using a PLA mold?
I mean, I've tried it before. I used mold release. This was with like a foaming urethane rubber, and it came out fine. That being said, you are doing rigid epoxy, so like it's not exactly the same thing. But honestly, like I think the mold release works super well. You might have to break the mold to get it out. If I were you, I might do like a base layer, like 1/8 of an inch of clear epoxy, put the tissue paper on top of that, so you have a little bit of room to sand in case you want to sand away any seams. But yeah, I mean, I think you should be able to get it out fine. The layer lines don't cause a ton of adherence.
Sweet. I'm gonna give it a go.
All right, nice.
For the shade of this clock, I have a couple requirements. I want the shade of the clock to diffuse the orbs of light. The second requirement is that I want the shade to have a natural, organic texture. And to achieve that, I'm going to use some crumpled up tissue paper, which is going to provide a nice, organic texture.
Right as I set up the mold to create the final lampshade, I made a last-minute decision. Instead of epoxy for the base layer, like Morley said, I decided to use Mod Podge and layer the tissue paper on top. I was just not convinced that the epoxy would break away from the mold, even with the copious amounts of mold release, and I didn't want to risk ruining the only mold that I had. After the first few pieces of tissue paper went on, there were early signs that this was going to fail.
Oh my God, bro. Oh, hell no.
The tissue paper would tear so easily when drenched with the glue. It was at this point that I ran out of my original type of tissue paper, and I had to switch to a different type that was much thicker. I immediately realized that the thicker tissue paper looked so much better, and it wouldn't tear when brushing on the glue. So cutting my losses, I scraped all my progress away, cleaned the mold, and started anew with the better paper.
Good morning. I got really lucky because last night I went outside and it had just started raining, so I was able to put this inside before it got too wet. And now it's fairly dry enough to start putting epoxy on. I did about 3 layers of tissue paper. I didn't really want to do many more than that because I still want to be able to see the lights through this. So we're going to use some thick set epoxy because that's what I have. And stop. 3. How long to stir Total Boat thick set epoxy?
Bruh.
Hey Siri, start a 3-minute timer. Trying to make a last-minute decision. Do I add the fiberglass? I'm gonna cut a tiny chunk off and see if it wets out, because I don't want this to be visible. We're doing fiberglass. I was so ill-prepared for this. The great thing about the thick set epoxy is that even though it's not meant for fiberglass layups, it has a really long working time of up to an hour. I'm feeling good about this. We're gonna make it work. I think I'm gonna have just enough. Now we let it sit for quite a while. I need to figure out if I can actually pull this out of the mold or if it's stuck in here permanently. It's definitely a bit more pliable than I wanted. Dang, this is actually not coming out so easily. Oh yeah, we're getting so close here. Oh, I just ripped it again, dude.
let's go. As I pulled it out of the mold, I couldn't help but notice how flimsy it actually was, and how uneven the edges looked. The texture and color was there, but it just didn't look professional. With some quick thinking, I modeled and printed a perimeter frame on the H2S and glued the pieces directly to the lampshade. My hope was that by adding a stiffer ring on the inside and outside edge, it would provide some rigidity in the shade and allow me to mount it to the clock more easily. When I popped it out of the mold, it felt much better, and the edges even looked more uniform. I remember when 3D printing technology was in its infancy, and you had to deal with nozzle clogs and constant print failures. I think Bamboo has really shifted the landscape of 3D printing, and they've come out with some of the easiest to use printers that provide you with high print quality, and I'm so incredibly grateful for their support. If you're a maker and want to explore 3D printing, I would encourage you to head to my link in the description to check out Bamboo Labs' website and get yourself a Bamboo Labs printer. Now it was time to add some structure to this clock. I printed these inside and outside walls, which I glued onto the main clock body. These will hide the internal electronics. I also printed some back panels to provide structural support and a place to hang the clock from. One of the unique features of the H2S and AMS Pro combo is the ability to do multicolor prints, so I was able to add a black logo into the orange back panel. Now the final piece of the puzzle that makes this clock function is the coding and electronics.
How does it connect an Arduino?
The clock is run off of an Arduino Uno, which is a programmable board that's the brain of the project. I spent many hours trying to code with ChatGPT, which is its own frustrating story, but I was eventually able to calculate the speed at which each motor needed to run for the clock hands to move correctly. Each stepper motor is run by a stepper driver, which is a tiny circuit board that communicates between the Arduino and the motor. The LED light's voltage on each orb is modulated by an LED driver that supplies the right amount of power to the lights without overheating them. I had no experience with Arduino or stepper motors prior to this project.
Looks like we got some lights turning on.
So this goes to show you that it's possible to tackle complex projects relying solely on online resources. As I put the final touches on this clock, I reflected on the original purpose of this project: to design a new and unique way to represent time. I wouldn't say I invented anything new, but I do think I was successful in making a remix of something that's existed for centuries. Taking a step back from the physical clock itself, this project forced me to reckon with time, the force that governs us all. Whether you like it or not, time is here to stay, and we have to learn how to use it to our advantage. Time is a fickle friend. There never seems to be enough of it, and it always moves too quickly. The main realization that I've had is I need to give myself more time when building things, and be honest with myself about how long tasks will actually take. I think it's easy to let time, or the lack thereof, become frustrating. But when I get in this headspace, I like to think of what my friend Ari Idkin said.
I think there's more of this thing about time giving you skills, time giving you knowledge, time is a gift. And I just think that's a way better way of looking at it.
Despite this being one of my most frustrating and complex projects, I'm certainly happy with the time I spent on it. Time truly is our most precious resource, and I think it should be treated as such.